Day 741 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2784. Check if array is good. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums. We consider an array good if it is a permutation of an array base n. Base n is equal to an array of integers 1, 2, all the way up to n minus 1, n. In other words, it is an array of length n plus 1, which contains 1 to n minus 1 exactly once, plus 2 occurrences of n. For example, base 1 is equal to an array of integers 1, 1, and base of 3 is equal to an array of integers 1, 2, 3, 3. Return true if the given array is good, otherwise return false. A permutation of integers represents an arrangement of these numbers. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get into the examples first, it's important to understand what what base n actually means, right? So base of 3, that just means we have 1, 2, right? Sorry, y'all, we have this 1, 2 right here. So remember, it's 1, 2 up to n minus 1. So if base is 3, 1, 2, that's up to n minus 1. Then we have 2 occurrences of 3, right? In this case, n would be 3, right? So that's why there's 2 3s, it says right here. In other words, it is an array of length n plus 1, which contains 1 to n minus 1 exactly once, plus 2 occurrences of n. So in this case, n is equal to 3, base of 3, right? So n is equal to 3, so it contains 1 up to n minus 1. So base of 3 is 3, so n is 3, so 1 up to n minus 1 would be 1 to 2, right? If n is 3. So that's this right here contains 1 to n minus 1 exactly once. So that's this 1 and 2 because n is equal to 3. Then it says plus 2 occurrences of n. So then we have 2 occurrences of 3 right here. And that's what makes this a good array, right? So now that we understand that, let's take a look at example 1. In example 1, we have our input nums equals an array of integers 2, 1, 3. The output is false. It says since the maximum element of this array is 3, the only candidate for n for which this array could be a permutation of base of n is n equals 3. However, base of 3 has 4 elements, but array nums has 3. Therefore, it cannot be a permutation of base of 3, which would be equal to an array of integers 1, 2, 3, 3. So the answer is false. So in this case, we have this array right here. The biggest number in this array is 3, right? So that means n would have to be equal to 3. So if n equals 3, that means for 1, we are going to need 4. This should have a count of 4, right? There's only 3 elements, but it should have 4 because there needs to be 2 occurrences of 3. So since we already know that n is 3, that means we know that the array should have 4 elements. So we could just check and see that this array doesn't have 4 elements, and we know this is not a good array. 1, because it's missing a 3, and 2, because it doesn't have 4 elements. So we return false. Now, just in case that didn't make sense, let's take a look at example 2 where the output is true. So in example 2, our input nums equals an array of integers 1, 3, 3, 2. This time the output is true. It says since the maximum element of the array is 3, the only candidate for n for which this array could be a permutation of base n is n equals 3. It can be seen that nums is a permutation of base of 3, which is equal to an array of integers 1, 2, 3, 3. By swapping the second and fourth element in nums, we reach base of 3. Therefore, the answer is true. So in this case, you can see this array has the right count. It has all the numbers we need. The only thing that different from this is the arrangement of numbers. However, that's where permutation comes in. A permutation of integers represents an arrangement of these numbers. So as long as we have the numbers, then it doesn't matter how they're arranged, as long as it's possible for us to arrange them in the correct order like this. So since this has the numbers that we need and the count that we need, no extra numbers, no numbers missing, then all we need to do is rearrange this array, then that means this is a permutation that we're looking for, so the output is true. Boom. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, our input nums equals an array of integers 1 and 1. The output is true. Explanation says, since the maximum element of this array is 1, the only candidate for n for which this array could be a permutation of base n is n equal to 1. It can be seen that nums is a permutation of base of 1, which is equal to an array of integers 1 and 1. Therefore, the answer is true. So this example is just like this right here, right? 1 is n is equal to 1, so that means we should have 2 elements in the array. We have our 2 elements. 1 occurs twice like it's supposed to, so the output is true. Boom. Now let's take a look at example 4, where it might be a little tricky because we have all the numbers we're looking for, but this time we have an extra number. So in example 4, we have our input nums equals an array of integers 3, 4, 4, 1, 2, 1. The output is false. Explanation says, since the maximum element of this array is 4, the only candidate n for which this array could be a permutation of base n is equal to 4. However, base of 4 has 5 elements, but the array nums has 6. Therefore, it cannot be a permutation of base of 4, which is equal to an array of integers 1, 2, 3, 4, 4. So the answer is false. So as you can see, once again, the largest integer in this array is 4. So that's how we know we're working with base of 4, right? Boom. So since we're working with base of 4, that means the output or the array should have 5 elements. But in this array it has 1, 2, 3, 4, 5, 6. So we already know it's not a good permutation because it has 6 elements. It has 2 1s. It should not have 2 1s. It says up here, in other words, it is an array of length n which contains 1 to n minus 1 exactly once. So in this case, n is 4, so it should this should have the numbers 1 through 3 exactly once. But this has the number 1 twice. So that's another way that we know that this is not a good array. So we return false as our output, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult. Now, the first thing we're going to do is we're going to find the largest number in the array. And in a valid good array, this number should appear twice. So we're going to say let n equal nums dot max, put a parentheses, put an exclamation point. Boom. Now, a good array should contain numbers from 1 to n with n appearing twice. So that means the total array size must be n plus 1. So we can handle that by saying if n does not equal nums.count minus 1, then we can open up the brackets and we could just return false right there. Boom. Let's come underneath this. And we're going to create a frequency array used to count the occurrences of each number from 0 to n. So we'll declare a variable called freq, and we'll set that equal to an array. Open up the parentheses. It's going to be repeating colon 0 comma count colon n plus 1. Boom. Now we're going to count how many times each number appears. So we'll come underneath this and we'll say for num n nums. We'll open up the brackets and we'll say freq square bracket num. Come outside of that, we'll say plus equals 1. Boom. Now the largest number in n must appear exactly twice. So we'll come underneath this and we'll say if freq square bracket n does not equal 2, we'll open up the brackets and we'll return false. Now every other number from 1 to n minus 1 must appear exactly once. So we'll come underneath this and we'll say for num n nums. We're going to open up the brackets and we'll say if num does not equal n and 2 and signs freq square bracket num, come outside of that, does not equal 1, we'll open up the brackets and we can return false. Boom. Now, if all conditions are satisfied, then that means the array is considered good, and we could just come right here and we could say return true. Boom, y'all, that should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. Let's see, and look at that, y'all. 1 millisecond beats dash percent of users. Not sure what that dash means, but I'll take it, y'all. And before we go, make sure you get one more look at the code. This is the top part. This was the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.